Okay, so this is physics chapter 15, problem 20. We have a rope 6 meters long, and at the end of it is a mass weighing 0.5 kilograms, and the weight of the rope is 29.4 newtons. We're asked to find the speed of the transverse wave at the bottom, the middle, and the top of the rope, and then find out if the tension in the middle of the rope is the average of the tensions at the top and the bottom of the rope, and if the wave speed at the middle of the rope is the average of the wave speed at the top and the bottom. Now first, find the speed of the transverse waves of these. We get the equation that the speed of the transverse wave is equal to the square root of the tension multiplied by the length divided by the mass. So, and to calculate that, we use the mass of the rope to start. So we have the 29.4 newtons and divide that by gravity. So 29.4 divided by 9.8 gives us a weight of 2.997 kilograms for the rope. And if we plug that into our equation, it comes to the speed, the transverse wave of the rope is the square root of the tension multiplied by 1.8. As the length divided by the mass of the rope will give you 1.8. So for A, for the bottom of the wave, our tension is going to be equal to the weight of the mass at the bottom. So for A, our speed is going to be that V is equal to the square root of 0.5 times 9.8 multiplied by our 1.8. And that equals out to be 2.97 meters per second for the speed of the transverse wave at the bottom of the rope. Now for part B, at the center of the rope, our tension is going to be equal to half the weight of the rope. So first we want to solve for our tension, and that T would be equal to 29.4 divided by 2. Then you multiply that. 29.4 divided by 2 plus the weight of the mass at the bottom times by gravity. It's going to be equal to your torque, or your tension, which is going to be equal to 6.37 newtons. And you plug this back into that equation for tension. So the speed at the center is going to be the V is equal to the square root of 6.37 times by 1.8, which equals out to be 3.39 meters per second. And then for part C, we have the speed at the top, and it's going to be the full weight of the rope along with the weight of the mass. So our tension is going to be equal to 29.4 plus half kilogram times by 9.8. And that's going to give us a tension equal to 34.3 newtons. Plugging that back into this equation, get the speed of the transverse wave equal to the square root of 34.3 times 1.8, which equals out to be 7.86 meters per second. Now, along with this, calculate the average between the top and the bottom of the rope, and you'll get that the average at the tension at the center of the rope is the average of the tension at the bottom and the top, but the speed at the center of the rope is not the average of the top and the bottom, because the average speed is equal to the square root of the tension. So, and that's everything.